Hi, this is Denisa, and in this video I'll go over how to write some code that proves that the reciprocal of the square root of 1 plus the square root of 3 and then plus 1 divided by the square root of 5 plus the square root of 7, etc. up to 999,999 is larger than 24. It's obviously easier to see when it's written out like this, as you can see here. I've derived this challenge from Codebymath, which is a website that teaches you how to learn code in the context of learning math, and it's a really good resource and I recommend you check it out. The website uses Lua to code, but I'm going to be using Python because that's what I'm learning. Okay, so you're gonna write a for loop to express this in code, and as you can see here, the one thing we can focus on when it's in the for loop is how much it increments by, and it can increments by 2. But one thing to notice is that the two terms are separated by a plus, so you can't say that it's 1 divided by the reciprocal of 1. How do you say this? The square root of 1 plus the square root of 3 plus the square root of 5 plus the square root of 7. It's 1 divided by the square root of 1 plus the square root of 3, and then plus 1 divided by the square root of 5 divided by the square root of 7. So instead of incrementing up by 2, you can increment up by 4. And it's easier to see when you have a code on hand. Okay, so we're going to have a sum that's equal to 0. We're going to have a for loop that goes... I'm going to explain how it increments first, right? So you're going to have a term 1, that's going to be this square root of 1, and then you're going to have term 2, which is then going to be the square root of 3, and then term 1 will be square root of 5, and then term 2 will be the square root of 7, and etc, etc. And well, we're going to have a for loop for I in, we can have an arbitrary value for now, 1 to maybe 1,000, right? And then you're going to want to increment that by 5, so 4 multiplied by 1 is our first value, and then to get to 1, I mean, it's a 4, you can see that's 4 because the jump from term 1 to term 1 in the next iteration has a difference of 4, as does 3 and 7. So we're going to have 4 divided by 1 minus 3, because 4 minus 3 is 1. And you're going to have 4i minus 1, and it checks out because if you this will be 4 1, and 4 multiplied by I is again 4, and then you'll have 1, and then you'll have 3, and then if you multiply it by 2, you'll have 8 minus 3 is 5, and then you'll have 8 again, minus 1 is 7, so you can see it checks out for the first 2 ones, and then if you repeat it up to 9,999, you can see that as well. And so if you're going to want to do this up to 9,999, since we're multiplying I by 4, you're going to want to do say up to 10,000 divided by 4, right? Which is 2,500. Since this range goes from 1 to 2,499, we can make that 1 more. And then you're going to add to these. Oh wait, first it'd be nice to put this in a separate variable. So term 1, that's the square root of term 1. As you know, the putting x to the power of 2 I mean, x to the power of a half is equivalent to the square root of x. And then you want to do the second square root because you're going to square them both. And then we can finally have the exact this one block. So sum plus the reciprocal of the two squares added together. I put the brackets wrong. It should be like this. And then we can display the sum of that, print sum, and it should be bigger than 24 if our code is right. Oh, there you go. It's slightly bigger than 24, but it is bigger than 24. So if this theory is right, our code proves that. And that's pretty much it, really. Thanks for watching, and go check out Codebymath.